Hello students, in this video we're going to look at how we design this box in front of us. It's a small box. It's going to be 120 millimeters by 120 millimeters square. Vertically it's going to be 70 millimeters approximately, and we're going to be using 19 millimeter wide material. An important feature of course is that this box uses a rebate joint on every corner, as we can see in this diagram. And we're also going to have a 3 millimeter thick base material on the bottom. Now, if you're in one of my classes, you'll be having a single piece of wood provided to you that is already 70 millimeters approximately in width, 19 millimeters in thickness, and approximately 500 millimeters in length, which is going to give you enough material to cut out the base pieces for the side. And the bottom piece, a 3 millimeter, in this case will be ply or MDF, will actually be provided to you pre-cut to the right size. So you'll be expected to cut the 4 side pieces and then do the rebate jointing to put it together and then put the base on as well. So let's have a look at how we go about creating this in SketchUp. So I'll just jump into SketchUp here. As always, create a new project. And most importantly, when you start any new project, remember to check your measurement. So go to the little information button, length and units. Make sure you are set for millimeters, and 0.0 for precision is acceptable. And then we're going to put that away. You can get rid of the little person if you want. They're not really needed at this point. And we're going to begin our modeling. Now, as we've been doing in previous models, start by thinking about the basic two-dimensional shape that you might want to begin with. And of course, each of these sides of the box are going to be simple rectangles as a basic shape that we then pull up into a three-dimensional piece. So I'm going to start with the longer side, which is going to be 120 millimeters long by 19 millimeters thick, and that's going to then be pulled up to 70, and we're later going to apply the rebates to that. So let's have a go. We're going to draw the basic shape, so we know it's a rectangular shape. We let go of our mouse and we type in our measurement. So we want to be 120 long, comma, 19 millimeters for our thickness, and press enter. And of course, it should look like it shrunk down in this case. We're going to zoom in. Now, of course, I am using a mouse, so I can use my scroll wheel to make it a lot easier. If you're not using a mouse, I strongly still encourage that you do. It makes life a lot easier in SketchUp. Let's go take our push-pull tool, grab the shape, pull it up by any amount, doesn't matter, just so long as we can see it is moving how we expect. Let go, type in our 70 millimeters for our height, and of course we're going to then press enter and it sets its correct height. So we now have our basic essentially piece of wood as if we cut this in class. We're now going to apply our rebates to this one. So we know the rebate needs to be 19 millimeters from the end, because that is the same as the thickness of the piece of material that's going to slot into that. And again, this is something that we've learned about in class by this stage. So we're going to start doing that with our tape measure. It's the easiest way. So I'm just having a little mouse issue there, sorry. So from the edge, let's come in, type in the 19 and press enter. And we'll do that on both sides. Very important that we stay on the axes, type in our measurements, and come both sides. Now remember, we can't push-pull with these lines because these are just construction lines. They're like temporary lines. So we're going to come and get our pencil now so we can actually fill in the part that we actually need. So using the intersection of the construction line and this edge, making sure we mark that point. Let's bring that line down to match the other end, and the same on both. So this has created now individual sections on our face, remember? So we can take our push-pull tool and we can see that each of those are separate, which means that we can push that one in by 9.5 millimeters, because of course that is half of the thickness that we want here. And of course we can come across the other side, do the same, push it in, type in our 9.5 and press enter. So we now have our two rebates shown. Take the rubber and rub out our construction lines, and we have a finished piece. Last thing we want to do to this piece before anything else is to highlight everything and turn it into a component so that we can move it around and duplicate it safely. Let's call this the rebate side and just press enter to save that. So I have one piece, but if I now just zoom out a little bit, want to think about a second one of these, because of course there are two sides to this. So what I'm going to do is simply, while that's selected, I'm going to copy it. So copy and paste. All right, and I'm going to put it over this side here. But this one's going to want to flip around 180 degrees to be facing inwards, because we've got one on each side. So take our rotation tool, make sure that we are rotating on this top axis here. So 1 click, 2 clicks with the handle. Check that it is rotating in the way that we want. And of course, then I can just type in my 180 for the rotation amount. So it perfectly rotates 180 degrees, and we are done with that piece. Now I'm going to jump back to the model for a second. These are the two pieces we've just done, this back piece and this part here with the actual rebates cut in. We now need to make this piece that goes in between. But it's important to note that it's not going to be 120 millimeters long. It's 120 from this corner to the very back corner, but we have to take into account the little bits, the 9.5 mil here, the 9.5 mil here, that we have for the rebate. So that 9.5 and that 9.5, if we add them up together, of course, we get 19. So really what we need is 120 millimeters from edge to edge minus the 19 that makes up the rebate, which means this piece in between is actually going to be 101 millimeters to get a total of 120 still. So we're going to model something that's going to be 101 millimeters long, still 19 millimeters thick and 70 millimeters high. So jumping back to the model that we are working on now, let's take our rectangle again and start with our basic shape. Now I could draw it crossways like I've been doing, but I know that later on I'm going to have to then rotate it 90 degrees to face this way. So why not start in that direction so that we don't have to do it some extra steps? So I'm going to draw it this way instead. The only problem there, if I look down at my bottom corner, I have to reverse the measurements when I type them in, because my smaller measurement 23 is obviously this measurement across at the moment, and my longer measurement 126 is obviously this way. So in this case, what I really want though is 19 still for the thickness. This has to be the first measurement this time. And as we just talked about, 101 for our second measurement, and press enter. So again, we've got our perfect shape. Take your push-pull tool and again, bring that one up by 70. We've done this lots of times now. And that is a finished piece now. There's no joint to do on this because the joints are done on the other piece. Let's highlight everything that makes up that piece. Now, it doesn't matter that some of this is behind in the selection because it's not completely enclosed, because of course this is one big component, so I'd have to draw something that enclosed all of it if it was going to be made part of the selection. So this is safe to do. And we'll right click and make a component out of that as well. I'm just going to call that side, nothing special. Like before, I need two, so I'm going to copy and paste that. I'm just going to put it roughly over this side here as well. So I now have all four pieces, two that we've done rebates on that were 120 millimeters long, and two that we've worked out need to be 101 millimeters to fit between. Let's start bringing those together. So I'm going to start with the one closest to me here. I'm going to bring this side to join into this rebate, and we know that we can lock corners, for example. So I'm going to lock this corner here to where it would touch this corner here. So using my movement tool, let's grab that corner and let's lock it in place there. Let's do the same with the other piece. I'm going to grab that one over there. I might zoom in a little bit closer. And again, I'm going to lock this inside corner to the inside of the joint this time. And finally, I'm going to choose the back part with the rebate. And again, I'm going to lock that in. So let's use this corner here and lock it with, done that wrong, sorry, back corner there, and lock it with this one here. Sometimes you might need to rotate to get a better view. Remember, you can pick any corner, just as long as you can see where they touch each other, you can then lock them together. And we have finished the frame of the box. Now, the last piece we need to model is the base, because of course, if I rotate this round, I can see straight through it at the moment. Now, there's two main ways you could probably do that. First one, of course, you could come over to the side, model a piece that's 120 by 120, and then pull it up to be, or down for that matter, to be 3 millimeters. And that's the base for your box there. You can grab that piece after turning it into a component. So let's do that quickly. Component, make component. I'm going to call this base. And of course you can move that into place. So I could take my selection moving tool, grab that top corner there and with a bit of playing, eventually get it to line up properly. There we go, it's just locked in now. And of course now I do have a base on my box. But there's another way you could do it that might be a little bit more easy in some ways, I guess. So let me just delete this base there. Another way I could do it, because each of these are components, I could just literally rotate around to look at the bottom. I could take my rectangle tool and locking from one corner to an opposite corner, I could literally draw that shape in. We know it's going to be the right size because it's matched exactly to the box because we've used the corner references. And it's not affecting the box pieces themselves because this is a square, even though I can see the lines through it at the moment, but this is a square drawn on top of other components, and those components are not being modified. So I can still take my push-pull tool then and pull that down, type in 3mm, and of course I've now got a base. I do want it to be a component still, and again I can grab my selection tool, I can draw a box that will grab all of that base, and the same as I said before, it's not going to affect the rest of it because I'm only selecting the whole base. None of the other sides are fully enclosed in this selection, so when I let go it is still only choosing the base parts. If I do look around, no other sides or parts were selected because they weren't fully enclosed in that selection box. So I'm still able to do that, make a new component and call this base. I'm going to call it base 2 just for reference. So there was two ways we could do that. So again, ended up at the same point though, where we have all our sides done and we have a base properly modeled on. The final thing I'd probably do at this point is just double check some measurements. So take your tape measure, do things like check your thickness is still correct, 19, so on and so forth. Or even better, grab your dimensions tool. Remember, if it's not showing up there for you, grab it out of the full set of tools by clicking on the 3 dots, grab your dimensions tools, and let's put some dimensions in. So for example, let's show that the full length here from corner to corner is 120. Let's show that the full length from corner to corner on that side is also 120, and maybe include the height there as well. Sorry, I've clicked the wrong part there. Height, being careful that you don't include the base at that point. That's going to be 70. If you want to show that the piece in between, for example, is 101, you can choose that. You can obviously show the thickness of the rebate if you wanted to, each of those pieces. So you can go through and show all the different measurements that might be relevant to prove that your model is correct. But also to help you then, if you needed to use this as a plan for actually physically building this later. So you could print this out, take a screenshot, etc., and you'd have all the measurements. And in fact, that is how I create the plan that I have available for you on Schoolbox as well. So once this is all done, save it, of course, as you go, and then you can submit this for assessment if that's what you need to do, or if you're just following this for your own interest, you now have a modeled box.